Well, I'm sure we have discussed a similar question through our videos, but there it was in a rectangular field, which is easier to solve. Here it has been made a little complex by saying that it is a triangular field, and that too a scalene triangle, because you see the sides are different, 26 centimeters, 28 centimeters and 30 centimeters. So at each corner of this triangular field, a cow has been fixed. A cow is tethered with a rope of length 7 meters. So of course, they can graze some part of the rectangular field. What part is ungrazed is the question here. Let's look at the solution. I'm sure the same question, it's a popular model that a cow or a goat is tied at one of the corners of a rectangular field and how much area is grazed or ungrazed. So total area of the rectangle minus area grazed by the cow. But that would be simple. The complexity here is that we have a triangular field and that too a scalene triangle. So it would be a little complex to identify what is the ungrazed area. Be careful, it is asking us to find out the ungrazed area. If it is how much area is grazed by the cow, then maybe it would have been a little easier. But in this case, how much area is left ungrazed by the cow. Now what do we do? Let's look at the triangular field here. So this is the triangular field. Of course, it may look like a equilateral triangle, but you know that the sides are different, 26, 28 and 30. So let's say this is 26 centimeters, this side here is 28 centimeters and here is 30 centimeters. And like the question says, a cow is tied at each corner, right? It is tethered at each corner of this rectangular field with a rope of length 7 meters. So this is a rope of length 7 meters, let's say. Here is a rope of length 7 meter and here it is 7 meters. So what happens? See, the cow has flexibility to graze. It has the flexibility to cover a region with a radius of 7 centimeters, 7 meters. You understand? It is fixed at this point and the rope length is also fixed. So what happens? The cow can cover this much of portion, which is a part of a circle. This much of portion, which is another part of circle, and this portion. Are you able to follow? So this area is grazed by the cow. This area here is grazed by the cow. This area is grazed by the cow. Are you able to follow? Right? It is like this. It is fixed at one point. You have a length, rope of length, some 7 meters. So you can move in a circular manner, right? Of course, it cannot go outside the triangular field. So we have to restrict it this way. So if you look at it, these are all portions of circles. These are all portions of different circles. See, now the challenge here is, like I said, the triangle is scalar. Had the triangle been equilateral, it would have been easy. Because we know that in an equilateral triangle, all these angles are 60 degrees. This is 60 degrees, this is 60, this is 60. So 60, 60, 60 makes it, you understand, 180, or you can understand how much of area is covered by the sector of a circle, right? You know how to calculate the area covered by a sector of a circle. Yes or no? So that would have been a little easier. The challenge is we do not know what the angles are. Equilateral triangle, this is 60, 60 and 60. So you can measure the area of each of the sectors, total area, and from the triangular area, if you subtract these three, you will get the remaining portion. What is required is this, ungrazed area. What we need is unshaded region here. How much is the ungrazed area is the question here. Now the interesting point here is, or the point to be noted here is, though it is a scalene triangle, the fact is that sum of the angles of a triangle is 180 degrees always. See, the point is, it becomes complex if you try to measure individual portions. But I club all of them. If I club all of them, what happens? It is some angle here, x, some angle here, y, and some angle here, z. Now x plus y plus z should be 180 degrees. That means if you connect all these three parts, you will get a semicircle, 180 degrees, right? 180 degrees is a semicircle. So what happens? If I connect all this, we'll have this, 180 degrees, which is a semicircle. This area is grazed. Are you able to follow? Irrespective of what the individual areas are, the total has to be 180. If it is equilateral, okay, 60, 60, 60, 180, right? There anyway, even if you try to calculate individual sector, it is easy because 60 degrees, you know the angle, you can measure the area of the sector. Here, because angle is not known, you cannot measure. But combination of all these three should always be a semicircle, right? Now you know how to measure the area of a semicircle. How do you do that? Pi r square by 2. What is r here? The length of the rope, 7 centimeters. So the area here will be equal to pi r square by 2, which is 22 by 7 into r square. The radius is 7 into 7 divided by 2. Simplify, 7 gets cancelled. This is 11 times 11 to 7, 77. So 77 meters squared is grazed by the cows. All the three cows together, 77 meters squared is grazed. Now let's find out the total area of the triangle. How do you measure the total area of the triangle? Scalene triangle. You know what the formula is. Okay? Area of the triangle will be equal to root over s into s minus a into s minus b into s minus c, where s is the semi-perimeter. Now what is semi-perimeter? 26 plus 28 plus 30. This will be 84 Yes or no? 26 plus 28 is 54. 54 plus 30, 84. 84 divided by 2, 42. So semicircle is equal to 42. S is equal to 42. Substitute now. So this will be 42 into 42 minus 26. These are A, B, C, right? Don't get confused, right? These are the three sides. 42 minus 26. How much is 42 minus 26? 16. 42 minus 28, 14. And 42 minus 30, 12. Now simplify this part. A smart person will not multiply. He'll try to split this in terms of factors such that he can find out the square root easily, right? Because anyway, square root is required. So let's try and split it. What happens? 42 we can take it as 7 into 6. 16 is 4 into 4. 14 is 7 into 2. And 12 is 2 into 6. Why are we doing this? See, under square root we have got 2 sevens. So if you take it outside, you'll get 1 7. Under square root we have got 2 6s. So if you take it outside, you'll get 1 6. Under square root we have got 2 4s. If you take it outside, you'll get 1 4. And 2 2s under square root will give us 1 2 outside. Right? 7 into 6, 42. 42 into 4. How much is 42 into 4? 168. 168 into 2. How much is 168 into 2? 336. 336 meters square. You know the total area, you know the grazed area. What is required? Ungrazed area. So we can say the final answer here will be equal to 336 minus 77. How much is 336 minus 77? 259. Right? Don't subtract 77. Subtract 80. 336 minus 80. Are you able to follow? 336 minus, or first subtract 70. 336 minus 70. How much will that be? Are you able to follow? 336 is not the answer, of course. 154 and 77 also cannot be the answer. I mean, I am not measuring it. I know that these three are not. Because 336 minus 77 minus 100 is 236. How can it be 154? How can it be 77? It's not possible. So of course the answer has to be 259, right? But like I said, break it into parts and simplify so that it becomes easier. 259 meters squared is the final answer. Right? Subtract 100, add 23. So 336 minus 100, 236. Then add 23. 236 plus 23 is 259. Or subtract 70, subtract 7. Subtract 80, add 3. Whichever way you do, final answer is 259. So the point is mensuration, of course. It's a formula oriented topic, but then as you see, many questions involve you to understand the right logic there. You must be clear with the reasoning there so that you can arrive at the answer quickly. Otherwise, this is a very complicated question. If you don't get this logic of all three areas becoming a semicircle, then it's very difficult to solve this, right? You cannot work to find out the individual angles and then measure them.